Welcome to my channel Maths with Lazy B. In this video, we'll be discussing a question of Jee Advanced from the topic of complex numbers. So the question is that for a non-zero complex number z, arg z denotes the principal argument of z with the values lying between minus pi and pi is included, minus pi is not included. So omega is the cube root of unity for which the principal argument lies between 0 and pi strictly, and they have denoted alpha as some principal argument of some complex number, and they are asking us to evaluate the alpha by pi. So we just need to figure out alpha to find out the final answer. So when we talk about argument, what is the definition of argument? Argument is the measure of the angle formed between the positive real axis and the line segment representing the complex number in the complex plane. This is the complex plane. This means this is the real axis and this is the imaginary axis. That means when we write a complex number a plus iota b, then from here, this is the a part from the real axis because it doesn't have the imaginary part. It is just a real number, and this is the imaginary part because it has iota with it. So from here we take b. So this is how we denote our complex number in the complex plane. Now, to find out the argument, either you go in anti-clockwise direction, which is positive, or in clockwise direction, which is negative. So anti-clockwise direction, that means you have to connect this real positive real axis with the line representing your complex number. So this is how you do it when you go in the anti-clockwise direction. But if you are going in the clockwise direction, then you have to do it in this manner. You start from the positive real axis and you go clockwise and you connect with the line representing a complex number. This is how you do it. So if I take a particular example, if this is 30 degree, then your argument is 30 degree in the anti-clockwise direction. But if you consider the clockwise direction, then it will be like this. So this will be 330 degrees actually from here. But since it is in the clockwise direction, it will be minus 330 degrees. So it will be minus 330 degree. The argument will also be 30 degree and minus 330 degree. So sign is compulsory. But your argument can take infinitely many values because it's not mandatory to stop here. If you are going in the anti-clockwise direction, then you can complete the full rotation of 360 degrees. You move from the positive real axis, you complete your rotation of 360 degrees, and then you join with the line representing your complex number. So it will be nothing but 30 degree plus 2 pi. So this is also your argument. And if you are going in the clockwise direction, then also you can complete your 2 pi rotations, but in the negative direction, so it will matter. So your argument can also be this: if you are completing 2 complete rotations of 360 degrees in the anti-clockwise direction, that means you start from here to complete one, then you move for one other before joining your line, your angle with the line representing your complex number. So this will be 30 degree plus 4 pi. So your arguments can be infinite. But when we come to the concept of principal argument, it has to be unique. So when we talk about the principal argument, in this question we denote it like Rz. It has to lie between minus pi to pi, where pi is included. So this is 0 angle, or this is 2 pi, 4 pi, whatever. But when we talk about the principal argument, this is just a 0 angle. It is not 2 pi, 4 pi. These representations work well when we are talking about arguments. But for the principal argument, this is just the 0 degree angle or 0 radians, whatever. 0 radians. Okay. Now, this is pi by 2 and this is pi But this is pi by 2 when we are taking it in the anti-clockwise direction. That is the reason it is positive. That means if we go from the positive real axis in this direction, anti-clockwise, and this is pi by 2 and pi. But if we go in the clockwise direction, then it is minus pi. Then it is minus pi. So it depends which direction we are considering. And principal argument says that if your complex number is this, and if you are rotating going in the anti-clockwise direction, and if you can connect this line representing your complex number with the positive real axis in the anti-clockwise direction, if you can do this, then it is fine. And if the angle is below pi or equals to pi, then it is fine. But if it is, for example, if this is your complex number, z, then if you move in the anti-clockwise direction, let me rub the before once. Okay, so if you move in the anti-clockwise direction, then your this angle will exceed pi. So this should not happen. Then you should take the shortest angle. That means you have to connect your positive real axis with the line representing your complex number through the clockwise direction. Through the clockwise direction. So in this case, this is going to be your principal argument. This. So if your complex number is in third or fourth quadrant, then you can't move in the anti-clockwise direction because it will exceed pi. So this should not happen. So you have, in that case, you have to consider the shortest possible angle. So this is the concept of the principal argument. And now the question says that let omega be the cube root of unity for which the principal argument lies between 0 and pi. They have explicitly mentioned this because when we talk about any nth root of unity, then that means you have to divide your 2 pi angle into n equal parts. And based on that, you get your n complex or n roots of unity, which are of course going to be complex. All cannot be real. All are real for when n equals to 1 and n equals to 2. But when you start from 3, you start getting complex roots. So you have your roots, nth roots of unity as this, then this, and you continue till 2 pi n minus 1 n, and the last one is 2 pi n upon n, which is nothing but the argument 0 or 2 pi, which represents the same complex number 1. So 1 is of course going to be the nth root of unity, because when you have to talk about the nth root of unity, that means your complex number should satisfy this equation. So 1 obviously satisfies this, and the other complex numbers that satisfy this are these. So when we are talking about the third root of unity, cube root of unity, that means divide 2 pi into 3 parts. So you'll be getting 0, 2 pi by 3, 4 pi by 3. Or if you are not taking it 0, then it is 2 pi. You can remove 0. So in that case, let us draw here only. So this is your whole angle 2 pi, or a unit circle. Consider this is a unit circle, and you have to divide this in 3 equal parts. So pi by 3. The next is going to be 4 pi by 3, and the third is going to be 2 pi only, or 0, whatever. But if you are taking it in the terms of principal argument, then this is 2 pi by 3, and since this 4 pi by 3 is more than pi, you have to take in the clockwise direction, as I told you earlier. So if you take it in the clockwise direction, then it will be minus 2 pi by 3. Because the distance, if you are dividing 2 pi in 3 equal parts, that means each root of unity should differ with the angle of 2 pi by 3. So this is 0 and this is 4 pi by 3 and this is the first angle, or this is 2 pi, so you will be getting minus 2 pi by 3. Because if this is 2 pi, for example, and you subtract 4 pi by 3, you will be getting 2 pi by 3. Since it is in the negative direction or in the clockwise direction, then it should be minus 2 pi by 3. So this is the principal argument. 4 pi by 3 was the argument. Principal argument, when the argument starts exceeding pi, then you have to consider your angle in the clockwise direction. So this is what we actually mean by the principal argument of the third root of unity. Since we are asked that here let omega be the third root of unity or cube root of unity such that its principal argument lies between 0 and pi. And what are the principal arguments? So 1 is the first root of unity and it has the principal argument of 0, since we can't consider pi because it has to lie between this and this. The third has the principal argument, the second has the principal argument 2 pi by 3, if this is the second root of unity, second third root of unity, or second cube root of unity, and this is the third one. This has the principal argument of minus 2 pi by 3. But you should satisfy this condition that omega is such that its principal argument is lying between 0 and pi, and both 0 and pi are not included. So 1 is out of consideration because it has the principal argument 0. So we can't talk about this. Minus 2 pi by 3 is also less than 0. So it is also not satisfying your condition. So this is the only possible case because this is actually 120 degree, which is less than 180 degree and more than 0 degree. So this means the principal argument of your omega given in the question is 2 pi by 3. Okay, now what remains is to solve and find the value of alpha. Solve this summation. So here alpha is given by principal argument of this. So if you see this, then this is minus omega, and if power is even, then you'll be getting positive sign. Again, if it is the power is odd, then you'll be getting minus omega cube. Fourth power, then it is positive. Similarly, minus omega 5 plus omega raised to power 6, minus omega 7 plus omega raised to power 8, and so on. So if you have to just solve it, then you can also use, you can see that the common ratio of these terms is minus omega, and since the total number of terms is 2025, then you can easily apply the sum formula of this and find out then apply the principal argument and find out that. But you don't need to do all these things actually. If you are good at observing things. Actually, if you see, then this is omega square minus omega cube plus omega raised to power 4 plus omega 6. Now you also know that omega is the cube root of unity, so this has to be satisfied by omega. That means you don't need a higher power at all. If this is 4, then you can reduce it to omega cube into omega. So this is 1, so you are left just with omega. Similarly, you can reduce this as well. Because using division algorithm, you can write any integer in the form of 3q plus r, where q is also in z, r is also in z, and r has the value 0, 1, 2, because remainder has the value 0, 1, or 2. When you divide any integer with 3, you'll be getting this as a remainder. This is because for any omega raised to power n, you can write it in this form. And once you are writing it in this form, you can separate these terms. And this is just 1 because omega raised to power 3 is actually 1. So this is 1 and you are left out with omega raised to power r. So that means you have only 3 cases to deal with. Because remainder can take only these many values, only 3 values. So any omega raised to power any power and omega raised to any power can be reduced to these forms only. You don't actually need to deal with the higher powers. Now, if you see it closely, this is minus omega, this is already omega square, 2 is less than 3, and this is nothing but 1. Now this is omega raised to power 3 into omega, so omega raised to power 3 is 1, so you're left out with omega only. And this is omega cube into omega square. This is again 1, so you're left out with omega square, and this is again 1. Now, you start from the beginning, then you have 1 as odd, and then you get an even number, then odd, then even, then odd, then even. If you're taking an even number of terms, then half will be odd, and half will be even. I'm saying this because half are odd and half are even, which leads to these terms getting cancelled with each other. Similarly, if you start with omega 7 plus omega 8 raised to power 8, and then raised to power 9 plus omega raised to power 10 minus omega raised to power 11 plus omega raised to power 12. Similarly, odd, odd, even, odd, even, odd, and even. And this is also going to follow this exact same pattern, because if you take any consecutive number and you know any consecutive terms and you know that you're starting with the remainder as 1, then it is 2, then this remainder is actually 0, then you'll end up getting the same type of terms. You collect any consecutive 3 terms and your and the first term says that you are getting the remainder 1. Then of course for the second one we'll be getting the remainder 2, and for the third one we'll be getting a remainder 0 only. So this is also going to follow the exact same pattern, because we are considering consecutive 3 terms for which the remainder is 1. Then for 11 it is 2. Remainder means that we are dividing the terms, the powers, with 3. And this is a multiple of 3, so the remainder is 0. So that means we end up getting the same pattern. These terms that cancel with each other, you are left with 0. That means you are actually collecting 6 terms together, and you are getting the sum as 0. So you have total 2025 terms in the summation, and you consider blocks of 6 terms. First block, the second block, but you can't reorder them. You have to take them in the same order. This has 6 terms, this has 6 terms. Similarly, you will not be able to complete this 2025 terms in natural number or a number of terms with number of blocks. You won't be getting exact number of blocks, because 2025 equals to 6 into 37 plus 3. That means if you start collecting a block of 6 terms, and you will only be getting 337 such blocks of 6 terms, because the other 3 will be left out. They don't have any we are just short of other three terms. So if you start collecting these 2025 terms together in blocks of 6 terms each, then you will be able to form just 337 blocks and the last 3 terms will remain. Fine. And if you simplify this using that, sorry, this is actually omega, which is given. Omega, omega, and omega. So because this sum gives 0, this sum gives 0, because 6 terms collected in pair gives you 0. This also gives you 0. Only the last 3 terms are remaining. Now you can solve these. So this gives the remainder 1. Actually, this was minus raised to power, minus omega raised to power. Some power is given. So this is, of course, or you'll be getting a minus sign, and this gives this as a remainder 1. This is E1, and this gives 2 as a remainder, and this is the multiple of 3. So this is omega raised to power this, and this is minus 1. And you know that the sum of these and nth roots of unity is just 0. It satisfies this relation. So because if you send this part on the right hand side, you'll be getting, substituting this over here, you get this. So to calculate alpha, you actually need to first find the principal argument of this part. You have to find the principal argument of this part, and the sum, we get the sum as 2 omega square. So to find the principal argument, now you know that if omega has the principal argument 2 pi by 3, then as I said that it is, if you take it in the anti-clockwise direction, then this is omega and this is omega square. And this has the argument as 4 pi by 3. But since it is exceeding pi, the principal, and this function refers as the principal argument, you have to take it in the clockwise direction. So this is minus 2 pi by 3. And notice that multiplying any complex number with a positive real number is not going to affect the argument or the principal argument, because if you see it like this is omega square. For example, if omega square has this value, a plus iota b, then this is a and this is b. If you multiply it with 2 or any positive real number k greater than 0, that means it should be positive. So it is just going to increase with the magnitude. The magnitude is going to increase, but the argument remains the same. The angle remains the same. Because you know that this point is AB and 2AB. 2B, if we multiply to omega square, then we get 2A plus iota 2B. So this just increases in magnitude, but this doesn't change or affect the principal argument or argument. But if you multiply any complex number with a negative real number, then the magnitude also changes and the argument also changes. So this 2 omega 2 is not going to actually affect our argument or principal argument, and it will be same as the argument of omega square, which is minus 2 pi by 3. Since this is minus 2 pi by 3, the final answer is 3 alpha by pi into minus 2 pi by 3, which is nothing but minus 2, which is the final answer. So thank you so much for watching this video and see you in the next video. Happy learning.